Hello and welcome as I take you round the world on beauties of mathematics. Join us as we discuss this radical expression. It's going to be mind-blowing, a lot you are going to learn. Now, when you talk about radical expression, you have an expression of this form. And we call this the radicand. This symbol here is what we call the radical symbol or sign. The n here is what we call the index or the power. Now, what do we mean by radical expression? As we have stated it, it means mathematical expressions that involve roots. So when you have a mathematical expression involving roots, we say they are radical expression. Now let me show you some of these roots it can involve. Examples of roots. You can have this. You notice in this there is no, we are not seeing any value of n here. But know you that when you have something like this, the n there is 2. We don't usually put that 2, but know that there's an invisible 2 here, and we call such the square root. The next is what we call this. When you have this, your n is 3, and we call this cube root. Know you that when you talk about square root, you talk about 2 numbers you can multiply to get the radicand. Now let me give you example. Example, you can have square root of 4. 2 numbers you can multiply to get 4 is what? 2. For this, you can have cube root of 27. 3 numbers you can multiply to get 27 is 3. Now let's take another example. Another one is the 4th root. Here you notice your n is 4. So we call such the 4th root. We also have the 5th root, 6th root, 7th, and the rest. So generally, we can represent it in this form. Okay, we just call it the nth root. So if you want to be particular to mention 5th root, that means your n will be 5. If it's 6th root, it will be 6, and the rest of them. Now that you have seen these examples of roots, now let me show you examples of radical expressions. Now, when you talk about radical expressions, let's look at examples. Some of the examples you can have root 5, you can have 3 root 2, you can have root x plus 4, you can have root 20x cube y, you can have cube root of 448 x cube yz. You can also have 2 minus root 5, and the rest of them. All these are examples of radical expressions. Remember, surd is also an integral part of radical expression. Surds are those radicals that their square root is not what? Rational. They are irrational roots. Okay, so when you talk about surd, you're talking about irrational roots. And know you that is also an integral part of radical expression. I hope that is clear. Now join me also. Let me show you the perfect squares, because it's going to guide us as we discuss this radical expression. Let's look at these. These are what we call the perfect squares. Know you that perfect squares are those numbers that their squares give you an integer, or that their square roots will also give you an integer. Okay, now when you have 1 is a perfect square. because you can express it as a square of 1 raised to power 2. Okay, now 4 is also a perfect square. You can express it like this in a square form of this nature. Now 9 is also a perfect square because you can have it like this. You can also say that their square roots, these numbers are also perfect squares because their square roots will also give you an integer. So whenever the square root of a number also gives you an integer, is also said to be a perfect square. So here, 1 is a perfect square because square root of 1 will still give me 1. Now, 4 is a perfect square because when you take the square root of 4, it gives you 2. 9 is also a perfect square because square root of 9 is going to give us 3. Okay, for 16 we have 4 squared, this is 5 squared, 6 squared, 7 squared, 8 squared, or this will be square root of 16 will give you 4, square root of 25 will give you 5, square root of 36 will give us 6, square root of 49 will give us 7, square root of 64 will give us 8, and the many of them we couldn't mention. Now let's look at this also. These are also perfect squares. I hope that is clear. It is perfect square because this has already been raised to the power of 2. Okay, so if you want to get it, you can simply say square root of this will still give you a whole integer. Okay, so you see it's a. So it means a to the power of 2 is also a perfect square. Now, this is also a perfect square. B to the power of 8 is a perfect square because you can express it in a square form of this nature. You can have it like this, b to the power of 4 raised to the power of 2. If you remember your indices very well, if you have b raised to power a raised to power m, according to your indices, you multiply the powers. So this will give you b raised to power am. So if you apply it here, if you multiply 4 by 2, it gives you back 8. I hope that is clear. So b to the power of 8 is a perfect square because you can express it in a square form. Now the next is this. M to the power of 4 is also a perfect square because we can express it in a square form to be m raised to power of 2, then raised to power of 2. So that when you multiply, you get back 4. Now we also have p to the power of 20 is a perfect square because we can express it like this. Okay, and so many of the examples. Now let's look at some rules of radicals and their examples. So here what this rule says is that when the roots are the same, okay, the nth root are the same, you can multiply the radicands. So you see, in this we multiply this. So we can have example, in the case of examples, we are using square roots, okay? So we can have example like the square root of 5 multiply square root of 3. You see that the roots are the same. So we can multiply their radicands. So in that case, we are going to have root of 5. Remember, this is multiplication, okay? So multiply by 3 is going to give us 15. Did you see that? It's only applicable if the roots, the nth roots are the same. Here also, this m here are serving as coefficients of these expressions. So here we can multiply this because the roots are the same. So we can have example, we can have 3 root 5 is multiplying 2 root, let's say root 3. The radicands, the roots are the same. You are free to multiply. So you can multiply this and this to give you 6. Then multiply this, it will give you 15. I hope you've seen that. Now for this is division. You can split your division provided the denominator is not 0. Okay, so you can split it, and in that case we are going to have example. You can have, when you have root of, let's say 20 over 16, you can apply this rule here to give you this. Okay, now the next example is the 4th one. Here you notice the roots, the radicands and the roots are the same. So this is what you have. So if you can have example like when you have cube root of, let's say, 5 is multiplying cube root of 5. So when you have this, you can simply say cube root of 5 raised to the power of 2. Okay, that is for that. Now you can also have this here. You have the index is the same as this also. So you can just cancel it out and the power will cancel the root to have a the radicand as your answer. So we can have example if you have square root of, let's say, 8 and is raised to the power of 2. These two will cancel this because what you have here is an invisible 2, as we have explained earlier, to have 8 as an answer. So finally here, what do? You are going to have, you can have square root of a, let's say square root of 9 raised to the power of 2. This is the same as square root of 9 all to the power of 2. Now remember, if you are still new to this channel, don't forget to give this channel a subscription. Let's know your thoughts about what you are doing in the comment section. Share it with your friends and also give us a thumbs up. We have come to the end of today's class and I hope you learned a lot. Let's see you in our next class. Bye-bye.